children? We are deducing Ohm's law from I equal to nAeVd. We are deducing Ohm's law. Ohm's law is V is equal to IR. V is equal to IR. That is Ohm's law. We are deducing this relation from I equal to nAeVd. I equal to nAeVd. This is the relation we are knowing. This equation we have studied. From that we are deducing V equal to I into R. So first what we did, a conductor, area cross section of the conductor is capital A, and N is the number density of electron. Number density means number of electrons per unit volume. And when we apply potential difference, E is the electric field, direction towards left, E is the electric field, L is the length of the conductor. Okay, this is the situation now. A conductor is having length L, and we apply a potential difference V. So electric field equal to E equal to V by L. From this relation, E equal to minus dV by dr. So E equal to minus dV by dr. From that, if the electric field is uniform, V by D, or like V by L, E equal to V by L. That relation we can take. And the electrons drift with a constant velocity, average velocity with which the electrons drift opposite to the direction of the electric field. That is drift velocity Vd equal to, this is magnitude. We have written magnitude here. If it is a vector, we have to write vector Vd equal to minus E vector E by m into tau. Vd equal to E by m into tau. So here we know this equation I equal to nAeVd. We know Vd equal to E by m into tau. Tau is the average relaxation time. What is relaxation time? Time between two successive collisions. So when we apply potential difference, electrons begin to move in particular direction, that is opposite to the direction of the electric field, towards right. See, electrons are moving towards right. And they move with a constant velocity. Average, that velocity is known as drift velocity. It is not accelerated actually. They move with a constant velocity, Vd, and its expression, it is directly proportional to the applied electric field. So how can you derive the Ohm's law from this? We are having this equation, and we know Vd is this, and we also know E equal to V by L. That also we know. Just substitute those values. I equal to E nAeVd. Always remember that formula. I equal to nAeVd. Okay. Vd we substitute here. E by m to tau. Then I equal to n E square A tau capital E by m. We got. E is equal to V by L. Right. E equal to V by L. That also written. Then I and V all got here. I and V. Then you take V from it. V equal to IR. That is what we have to prove. So from this relation, V by I. V you can take. V is taken cross multiply. So MLI equal to N E square A tau V. Therefore, V equal to ML by N E square tau A into I. So V is equal to some constant. This part is a constant. M by N E square tau into A. It's a constant because see, M is the mass of the electron. N is the number density of free electrons in a material. For example, copper, it is a constant, 10 raised to 29 per meter cube, like that. Number density, number of electrons per unit volume, like that. That is constant for copper, but for another material it will be different. N will be different for another material. E, charge of electron, that's constant. Then for a particular, for example, if you have taken copper wire, this tau is also a constant, a relaxation time. Okay, so this part is a constant. M by N E square tau is a constant, and into L by A. L, for example, this length, we know we are not changing the length in between the experiment, the same length. So L by A, directly proportional to L, inversely proportional to area cross section. So this is part R. R is equal to rho L by A. Rho L by A. Rho is this. Rho depends upon nature and temperature of the material. Relaxation time. Relaxation depends upon relaxation time depends upon temperature. Temperature increases, collision, that means collision will be more frequent, time reduces, more frequent collision take place. So relaxation time decreases. So I'll ask question, children, what is Ohm's law equation? Nivedita, what is Ohm's law equation? Nivedita, what is Ohm's law equation?
V is equal to Ri.
Sagar, what is the relation connecting current and drift velocity? Sagar, current and drift velocity. Srirag, what is the relation connecting current and drift velocity?
I equal to nAeV.
Correct. What is the expression for drift velocity? Tamanna, Villuraj. Tamanna, Villuraj. Drift velocity equation. Tamanna, Shaju.
V is equal to IR.
Drift velocity equation.
IO.
എന്താണ് വി ഡി എന്നാണ് നമ്മൾ എഴുതുക, സഫിക്സ് ഡി, വി ഡി.
VD is equal to minus EM by tau.
ഈ ബൈ എം ഉണ്ട് കേട്ടാ, ബൈ ഉണ്ടാ ഇവിടെ. ഈ ബൈ എം ഇൻറ്റു ടോ. വാട്ട് ഈസ് ടോ? അറിയില്ല അല്ലേ? അറിയോ ഇല്ലെന്ന് പറ.
ടീച്ചർ
അറിയില്ല. ടോ എന്ന് പറഞ്ഞാൽ ആവറേജ് റിലാക്സേഷൻ ടൈം. ആവറേജ് റിലാക്സേഷൻ ടൈം. ദ ആവറേജ് റിലാക്സേഷൻ ടൈം എന്ന് പറഞ്ഞാൽ when we apply potential difference, the electrons will be accelerated towards the positive end of the battery. And when they move, there will be collision between the ions of the conductor, positive ions and other electrons of the conductor. The time between two successive collision, that is average relaxation time. അപ്പോൾ ബേസിക് അന്ന് പഠിപ്പിച്ച റിലാക്സേഷൻ ടൈം അറിയില്ല, ലിഫ്റ്റ് വെലോസിറ്റി അറിയില്ല, പിന്നെ എങ്ങനെ നമ്മൾ ഇത് ഡിറൈവ് ചെയ്യും? ഇതൊക്കെ കണക്റ്റഡ് അല്ലേ? ഇതാണ് ഇപ്പം എല്ലാവരുടെയും സ്ഥിതി എനിക്ക് മനസ്സിലായി. വെറുതെ ഇങ്ങനെ ഇരിക്കുകയാണ്, ഒന്നും ശ്രദ്ധിക്കുന്നില്ല. വേസ്റ്റാണ്, വെറും വേസ്റ്റ്, ടൈം വേസ്റ്റ്. എന്നിട്ട് ഇനി ഇതെല്ലാം ആദ്യം പരീക്ഷ വരുമ്പോഴേക്കും ഒന്നും ഉണ്ടാവില്ല. I equal to അപ്പോൾ വി ഡ്രിഫ്റ്റ് വെലോസിറ്റി ഈക്വൽ ടു ഇ ബൈ എം ഇൻറ്റു ടോ. Then next we can substitute. Okay, I equal to nAeVd. We are substituting Vd, E by m into tau. Then capital E. What is the relation between electric field and potential difference? Gaudam, are you there? Ritu Parna, what is the relation between E and V? Electric field, potential and length. We apply electric field across the length L of the conductor by applying by connecting a battery. Ritu Parna, Riya, Nana, Nana Prakash and tell relation between E, V and
E equal to negative dV by dS.
E? Yeah.
Equal to negative dV by dS.
dV by dr. That is in the case of varying. Potential varies with distance. Here, electric field is constant. Constant electric field is applied. Understand? So we can write E equal to V by R, like V by D, V by L. And V is the potential difference applied across the length L. E equal to V by D. That V by L. That formula is applied here. Then from that, what you have to take from this equation, what you have to take to deduce Ohm's law? To deduce Ohm's law, Mitra, what you have to take from this? Mitra?
Yes, teacher.
What you have to take from this to deduce Ohm's law? What is Ohm's law equation?
V equal to, I equal to nAeV by m into V by L.
You have, see, when you substituted, we got this equation. So we have to deduce Ohm's law from this. So V is proportional to I, അല്ലെങ്കിൽ V equal to IR എന്ന് പ്രൂവ് ചെയ്യണം. മനസ്സിലായോ? V equal to IR. അപ്പം V അതിൽ നിന്ന് എടുക്കണം. മനസ്സിലായില്ലേ? Take V from it. Take V from it. So M by N square to L by A into I. M by N square to L by A into I. Okay. Then this part, what is this part? This is a constant for a particular material, R, resistance, V equal to R into I. That is Ohm's law. So now we deduced Ohm's law from it. So first step, I will ask to Megha KP. What is the relation between current and drift velocity? Megha. സമയം കളയാണ്ട് റെസ്പോണ്ട് ചെയ്യുക, കിട്ടിയാലും കിട്ടില്ലെങ്കിലും. മേഘന
I equal to nAeV.
ആരാണ്? മേഘനയാണോ?
അതെ.
I equal to nAeV. What is VD in that? മേഘന പറ, what is VD?
Drift velocity.
Equation പറ, drift velocity equation പറ. എല്ലാതും ഇതിലുണ്ട്, എന്നിട്ട് അതൊന്നും നോക്കി പറയാൻ പോലും പറ്റില്ല എന്ന് വെച്ചാല് എല്ലാം ഇതിലുണ്ട്. E by M into tau. And what is capital E? What is capital E? എല്ലാ ഇക്വേഷനും ഉണ്ട്, എന്നിട്ട് അത് ഏതാന്ന് കണ്ടുപിടിച്ച് പറയാൻ പറ്റണില്ല. വാട്ട് ഈസ് ക്യാപിറ്റൽ ഇ ഇക്വേഷൻ? സബ്സ്റ്റിറ്റ്യൂട്ട് ചെയ്തിരിക്കുന്നത് ക്യാപിറ്റൽ ഇക്ക് ഇവിടെ എന്താണ് സബ്സ്റ്റിറ്റ്യൂട്ട് ചെയ്തിരിക്കുന്നത് മേഘന? ഡി വി ബൈ ഡി ആറിന് പകരം ഈ പർട്ടിക്കുലർ സിറ്റുവേഷനിൽ അതെന്തായി? വാട്ട് ഈസ് ദ പൊട്ടൻഷ്യൽ ഡിഫറൻസ്? വാട്ട് ഈസ് ദ പൊട്ടൻഷ്യൽ ഡിഫറൻസ്? പൊട്ടൻഷ്യൽ ഡിഫറൻസ് കണ്ട, ബാറ്ററി കൊടുത്തപ്പോൾ എത്ര പൊട്ടൻഷ്യൽ ഡിഫറൻസ് ആണ് ഇവിടെ കിട്ടിയിരിക്കുന്നത്? വി ആണ് പൊട്ടൻഷ്യൽ ഡിഫറൻസ്. വാട്ട് ഇസ് ദ ലെങ്ത്? ഇ മൈനസ് അല്ല, അത് എല്ലാണ് ലെങ്ത്. ഇ എന്ന് പറഞ്ഞാൽ ഇലക്ട്രിക് ഫീൽഡ് ആണ് കേട്ടാ. കണ്ടാ, അപ്പൊ ഈ പറയുന്നത് ഒന്നും അങ്ങോട്ട് കയറുന്നില്ല എന്നുള്ളത് മനസ്സിലായി. ഈ ലെങ്ത് ഓഫ് ദ കണ്ടക്ടർ അല്ലേ. ഇ എന്ന് പറഞ്ഞത് ഇലക്ട്രിക് ഫീൽഡിന്റെ ഡയറക്ഷൻ ഇങ്ങോട്ട് മറിച്ചു എന്നേ ഉള്ളൂ. മനസ്സിലായാ? പോസിറ്റീവ് ടു നെഗറ്റീവ് ആയിരിക്കും ഇലക്ട്രിക് ഫീൽഡിന്റെ ഡയറക്ഷൻ. ഓക്കെ, ഇവിടെ ശ്രദ്ധിച്ചിരിക്കുക, അവിടെ ഇരുന്ന് ഉറക്കം തൂങ്ങിയിരിക്കാണ്ട് കേട്ടാ ക്ലാസ്സിൽ എടുക്കണത്. ഗ്രാമ്യ?
Yes, teacher.
Electrons move in which direction? Towards right or towards left? Here positive is connected, here negative is connected here. Electrons
Towards positive side.
Electrons move towards positive side. Electric field in which direction?
Towards negative.
Where to where? Electric field direction. Where to where? Positive, negative or negative to positive? Positive to negative or negative to positive?
Positive to negative.
Positive. This end is positive, this end is negative. Okay. See, positive is connected to the right end. So, this is the direction of electric field. Understood this arrow mark direction? This arrow mark shows the direction of Ramya. Parayu.
Electric field.
Electric field. Okay. Well, this is the way to derive the expression for Ohm's law from I equal to nAeVd. Okay. I think it is clear to you. ശ്രദ്ധിച്ചവർക്ക് മനസ്സിലായിട്ടുണ്ടാവും എന്ന് വിചാരിക്കുന്നു. അല്ലാത്തവർ പിന്നെ എന്ത് ചെയ്തിട്ടും കാര്യമില്ല. അല്ലാത്തവർ എന്ത് ചെയ്തിട്ടും കാര്യമില്ല. പഠിക്കണം എന്ന് ആഗ്രഹം വേണം. ഉറക്കത്തിൽ നിന്ന് എഴുന്നേറ്റിരിക്കണം. ശ്രദ്ധിക്കണം. എന്നാൽ മാത്രമേ കിട്ടുള്ളൂ. അല്ലാണ്ട് ഒരു കാര്യമില്ല. ഓരോ ഇക്വേഷൻ പഠിച്ചത് അവിടെ ഇട്ട് പിന്നെ ദിവസം വരുമ്പോഴേക്കും ഒന്നുമില്ല. ടീച്ചർ പിന്നെ ആദ്യം അത് മുഴുവൻ പറഞ്ഞ് പിന്നെ എങ്ങനെ പോർഷൻ നീങ്ങാ പിന്നെ ഓക്കെ. Okay, this is the derivation notes. It is given here. Its note is this. Okay, you can study that. Rho equal to m by n square tau we got from that. That is the resistivity of the conductor. Resistivity or specific resistance. It depends upon nature of the conductor. N denotes that. Nature, that means number density of free electrons in the conductor depends upon material, copper, aluminum, silver. For such material, N will be different. So, resistivity depends upon nature and also the temperature. That temperature, when temperature increases, collision becomes more frequent and relaxation time decreases. Time for collision decreases when temperature increases. They vibrate more frequently and relaxation time decreases. So, resistivity depends upon nature of the material and relaxation time. And here, so that you should know varying factors, the factors on which resistivity depends, nature of the conductor and relaxation time. Then classification of materials in terms of their resistivity. This resistivity is a very important property of the material. And based on that property, materials are classified. So some material are very high resistance and thereby very high resistivity. Resistance more, resistivity also will be more. And resistance is more. So, depending on the property of the resistivity, materials are classified into different groups: conductors, insulators, semiconductors. And we know which are good, which of are less resistance among these three children. Less resistance: conductor, insulator, semiconductor. Less resistance is conductor. So, high resistance will be for which one?
Insulator.
Yes, insulator will have high resistance. High resistance material will have high resistivity also. Okay, resistivity also. Rho equal to RA by L. So R depending on R, resistance more, resistivity more. Rho equal to RA by L. So directly proportional to resistance. Resistivity is directly proportional to resistance. So insulators have a very high resistance, the very high resistivity also. 10 raised to 14 ohm meter. Ohm meter is the unit of resistivity. And conductors, very low resistivity. 10 raised to minus 8 ohm meter to 10 raised to minus. See, very small resistance or resistivity. But insulators very high. This is plus 10 raised to plus 14, 10 raised to plus 16. Very high resistance for insulators. They do not allow the current to flow through them, insulators. But semiconductors, conductivity or resistivity in between them, 10 raised to minus 6 to 10 raised to plus 4, like that, in between them. These are the materials whose resistivity lie in between that of conductors and insulators. Example, you must know conductors, example, all metals, aluminum, copper, silver, etc. Insulators, mica, wood, glass, etc. And semiconductors, gallium, silicon, gallium arsenide, etc. Semiconductor, one chapter is there for you to study, last chapter. Gallium, silicon, etc. Conductivities, resistivities in between that of insulators and conductors. Then non-ohmic devices or limitations of Ohm's law. Ohm's law, what's the nature of Ohm's law? V is proportional to I. when you plot a VI graph for a material which obey Ohm's law, what is the nature of VI graph? M.A. Muhammad Adil, what is the nature of VI graph when V is proportional to I? M.A. Muhammad Adil. Are you there? Devika, what's the nature of VI graph when V is proportional to I? According to Ohm's law, V is proportional to I. What's the nature of VI graph? Devika. ഞാൻ ടെൻഡൻസ് തരില്ല കേട്ടോ മിണ്ടാത്തവർക്ക്. Aisha, what is the nature of VI graph?
Ma'am.
What's the nature of VI graph for a material which obey Ohm's law? V is proportional to I എന്ന് പറഞ്ഞാൽ VI graph എങ്ങനെയാണെന്ന് അറിയില്ല. അറിയില്ല അല്ലേ? അപർണ, ആർക്കെങ്കിലും what is the nature of VI? What is the nature of VI graph when a material obey Ohm's law? Straight line. It will be a straight line. See, this VI graph will be a straight line when they are directly proportional. So, actually, if a material obey Ohm's law, we get a straight line. If a material do not obey Ohm's law, we get a curved line. It will be curved, not proportional. This part you see, it is a curve. So that means it is not obeying Ohm's law. Up to this part it is obeying Ohm's law. After that we get a curve, means it is not obeying Ohm's law. So non-ohmic material, it is a non-ohmic material. So slope will be different. 1 by slope VI graph, 1 by slope gives what? Alok, 1 by slope gives what? Slope is I by V. 1 by slope is V by I. 1 by slope. Alok. 1 by slope. Resistance. ഒരാളോടും ചോദിച്ചിട്ട് കാര്യമില്ല, ഒരെണ്ണവും ശ്രദ്ധിക്കില്ല. Slope is, see, slope of this line, that means tan theta. Tan theta is, we already have calculated that before while explaining Ohm's law. So tan theta is, that means I by V. Therefore 1 by tan theta will give V by I. V by I is resistance. So resistance will be different here. This part, straight line part resistance is constant and curved part resistance will be different. So resistance value is not unique. That is what we are getting. Those devices which do not obey Ohm's law are called non-ohmic devices. Non-ohmic devices. Semiconductor diode, liquid electrolyte, transistor, etc. do not obey Ohm's law. The relation V by I equal to R is valid for both ohmic and non-ohmic devices. The value of R is constant for ohmic conductors, but R is not constant for non-ohmic devices. See, these are non-ohmic devices. We can plot the graph and we get resistance also. V by I will give resistance, but you know, here you can see this part one resistance, this part another resistance. Here also we can find resistance. So it is valid. Ohm's law is valid for all these materials, but for an ohmic material, R is constant. Non-ohmic material, R is not constant, varying. Different part, resistance is varying. That is the difference. For all non-ohmic devices, VI graph has the following characteristic. See, non-ohmic materials graph is this. See, it is not a straight line, curved line. Here, this is the graph, VI graph for a semiconducting material. The figure 1, this figure, the relation between V and I is non-linear, and this is also a curve semiconductor. And here you see VI graph. See, V for particular value of I, we are getting 1 voltage here, 1 voltage here, 2 voltages we are getting for one particular voltage. But if a body obey Ohm's law, we get 1 voltage for 1 current. But this material is not obeying Ohm's law, so we are getting different value of potential, different value of potential for the same current. And negative resistance also, you see, up here this part positive resistance and this part it is negative resistance. When you calculate the resistance, it will be negative. 1 by slope gives resistance. I is taken along y-axis. X is taken along, voltage is taken along x-axis. So 1 by slope gives resistance. I here V is varying. So it is taken along x-axis VI graph. The relation V and I depends on sign of the voltage. That is the second graph. The relation between V and I is not unique. There are more than one value of V for the same current. Gallium arsenide light emitting diode. That's graph. So these are the graphs for the material which do not obey Ohm's law. The material which obey Ohm's law, we get straight line graph. VI graph is a straight line, 1 by slope gives resistance. But the material which do not obey Ohm's law, we get a curved line like this. Relation between V and I is non-linear. Non-linear. It is not proportional to I. V is not proportional to I. Only up to this part it is proportional, then it is varying. Then this, sign of voltage, positive voltage applying we get one current, negative voltage applying we get another graph like that. Sign of voltage, current depends upon sign of voltage. Negative voltage we get another value of current. That is semi-conducting material. And this one, for a particular value of current, we are getting two values of voltage. So what is an ohmic material? What is an ohmic material? The material which obey Ohm's law.
Ohm's law.
Non-ohmic material means material which
Which do not obey
do
Ohm's
not obey Ohm's law. Example, that examples are given. Non-ohmic devices, or that are the limitations of Ohm's law. Non-ohmic devices, the graph will not be a straight line. That